Hello everybody and welcome back to Dinosaur Days. It's been a long time since I posted my last video, but I feel kind of like a little bit bad because I'm pretty sure I promised a video soon after the last one and I just got busy with so many other things, and YouTube was kind of at the back of my mind but never a priority, at least for the last year or so. I have, however, taken a renewed interest in it, so hopefully I'll be able to upload videos more often. This one in particular is going to be kind of a lower quality than the previous ones were, which I know none of my videos have ever been top quality. Like, I'm using a free video editor, so eventually I'll get that sorted out too. I hope to start taking YouTube a little bit more seriously. So, with that being said, I wanted to talk today about dinosaur reproduction a little bit, and some of the deformities that in eggs that can tell us how dinosaurs reproduced, and in a sense what their biology was like when they were alive. And so basically when it comes to eggs, as you can see on this paper, I've drawn up some diagrams, and the top diagram is a malformation or kind of a pathology that we see in mainly birds, or really only birds. Let me rephrase that. We only see it in birds. And it's known as ovum in ovo, where basically you have an entire egg inside another egg, and it basically causes the egg that is encasing the smaller egg to be abnormally large. And a result of this is that when the bird is trying to lay the egg, it results in the death of the mother. Not always, but a lot of the time it does. And because there's an egg inside of another egg, the embryo in the encasing egg is usually smashed or damaged in some way and is not viable. And the embryo inside the encased egg is essentially suffocated or isn't viable either. It generally dies as well. And this is something that's exclusive to birds, and again, it's identified by an oversized egg. Like you might see an egg like 2 or 3 times the size of a normal bird egg, and you crack it open, and right inside there is another fully developed egg, or an egg that's been fully formed, has its own shell and everything, just encased inside this other egg. It's really kind of a strange thing to see. And the lower image here is a deformity in the deposition of eggshell itself, because inside the mother's body, essentially what's happening is you have the egg not encased in anything, and it's coated in a calcite shell before it's laid by the mother. And this happens in layers. And usually, like in a healthy situation, the eggshell is laid down in a pattern such that the pores, there's little tiny pores in the eggshell, and these are pores where gas exchange happens. So the carbon dioxide leaving the egg, and usually oxygen and other gases entering the egg, so that the embryo can survive. And through basically what happens is, what I was going to say is that the eggshell's laid down in such a way that the holes or the pores are able to match up and provide that gas exchange venue where, or venue is not the right word, but you know what I mean, the right situation where gas exchange can occur. I'm drawing a blank on words right now, I guess. But anyways, and you get a healthy egg that will hatch and provide a baby bird. But in or reptile, usually, because this is a deformity that I should say right now we only see in reptiles. So the first one, ovum and ovo, is bird exclusive. This situation I'm talking about now is reptile exclusive, and it's seen a lot in turtles and some other reptiles as well, but it occurs a lot in turtles. And also this is important because this is the... I'll actually get to that in a second. Let me finish talking about it first. So in the malformed eggs, you get a situation where inside the mother's body, the calcite shell is laid down in a pattern that blocks the gas exchange channels in the eggshell. So you have pores in the egg, but they don't line up the way that they should, and it results in a clogged pore. So basically the pore might be there on the surface, but lower in the shell, in terms of the layers of the shell, it will be blocked by another layer of shell, and therefore gas exchange can't occur through it. And essentially what happens is the embryo ends up suffocating and dying because it can't get any oxygen. And I've drawn the diagram here. The first diagram would be kind of like how the eggshell layers look under a microscope or something. And I've kind of indicated with... this is a method we use in geology to denote rocks of different lithologies. And so if you find like a sandstone or something, you might mark it with X, and then a shale you would mark with lines, and then, you know, another sandstone layer you mark with X's again to denote that those two layers are sandstone and the one in between is shale. But anyways, I digress on that note, on that end. So basically, eggshells deposited, when you take a cross-section of it, it looks like a series of rings. And I kind of did a drawing here of a magnified version of what that would look like in terms of the alignment of the pores in each ring of shell. And so on the outer layer, you have like a normally deposited eggshell where the pores are where they should be. And then underneath that, you have an abnormal shell where the pores are not where they should be. And that's shown as the dashed line layer. And then under that, you have a third layer where the pores were deposited normally again. And that's not always the case. Sometimes you'll have just like a random... It really depends on the health of the mother. And this is a simplified case of it, but essentially, it's a condition where the eggshell is mismatched, essentially. And so instead of, again, to reiterate, the pores do not line up properly, and they are blocked, and gas exchange can't occur, so the embryo dies. And in terms of dinosaur reproduction, and having their eggs tell us something about their biology, the question becomes, well, did they reproduce more like birds, since it seems like theropod dinosaurs were either a sister group to birds or possibly ancestral to birds. We're not really sure which at this point, but in the TVs and books, they're all going to tell you that they're ancestral to birds, but that's not entirely clear. I'm not sure if I've mentioned that in any of my previous videos or not, but I'll make a video dedicated to that later. And or were they more like reptiles? And it's important to remember that dinosaurs were in fact reptiles. They were not birds. They were reptiles. And what we see in their fossilized eggshells is really that we never see this ovum and ovo condition. Like, to my knowledge, that's never been discovered in a fossilized dinosaur egg. However, we do see this mismatched eggshell condition, and there's a name for this too. I just can't think of it off the top of my head right at the moment. And that's what we see in dinosaur eggs. And so that tells you that in terms of the environment the eggs in inside the mother, and how the eggshells lay down inside the mother, it was more reptile-like, or closer to a turtle than it is to a bird. And considering that dinosaurs were reptiles, that makes sense. And to me, I think it's important to keep that in mind as well, because of the fact that there is so much literature out there and media out there portraying dinosaurs as warm-blooded bird-like animals. And which they weren't. And again, I'll get back to some of these ideas in later videos. And I'm going to cut this video now because I don't have much time right at the moment. But I just wanted to make a short little... This is something I was just discussing with a colleague, and so I wanted to make a short little video discussing it with you guys, and hopefully you learned something, and I will catch you later.